Let's go on to the first problem. First problem seems fairly simple as the instruction at the top, at least the category says finding perimeter. I already have a picture here. It has a hint there to draw yourself a picture, and a picture is your best bet in order to get your dimensions correct. Let's read through. You want to frame a picture that is 8 inches by 10 inches with a 2-inch wide frame. What is the perimeter of the picture? What is the perimeter of the outside edge of the frame? I'm going to say a few things about my picture here. Zoom in. Take a minute and draw the picture there. Right? Don't leave it out so that you make sure you get your dimensions okay. When we're finding the perimeter of the picture is here, my inner rectangle that's in my bluish colored pen. And you can see I have listed dimension 8, dimension 10. So we could surely add up the sides there for perimeter. The 2-inch wide frame, the 2 inches goes on each side of our 4-sided picture. So we want to make sure that really when we're looking at kind of the width of the picture, we have to add 2 inches over here on the left-hand side and 2 inches of framing on the right-hand side to have the dimension of the frame be 12. And then the same goes for the length of our frame here. So let's write down our calculations for perimeter. We'll do the picture first. So perimeter, and I'll put a subscript pic, perimeter, subscript pic. And we're going to add up the sides. 8 plus 8 plus 10 plus 10. So the perimeter of the picture is 36 inches. Right. Make sure you include a unit. Perimeter is a one-dimensional calculation, so we just put inches. We're going to do the perimeter of the frame. All right, so P subscript, I'll put FR for frame. And we're going to add up the dimensions of the frame. So as long as we wrote down the right dimensions by looking at the picture, we should have the perimeter correct by adding up the sides. And 12 plus 12 plus 14 plus 14 is 52 inches. Right, again, include your unit. Right, you can pause if you need to look over anything. We're going to go to the next problem. Problem 2 is finding circumference and area. I already wrote down some formulas because this circumference and area is of a circle with radius of 9 meters, and it says to leave our answer in terms of pi and to the nearest tenth. So we're going to do some rounding and we're going to leave it in terms of pi. Make sure you know how to do that. So we'll do this problem so that you can see that. Circumference formula I have written, so we'll do that first. We only really need to know the radius of the circle, which we do. The radius is 9. And in terms of pi means that we'll see pi in our answer. However, we will not multiply pi by the 2 or the 9. We'll simply multiply 2 times 9, which is 18. And we just put the pi right beside and include our unit, meters. Circumference in terms of pi is 18 pi meters. Now, if we would go to our calculator and end up doing some rounding here, we take the calculator. The calculator, nicely enough, has a button for pi. So give me a minute to adjust here so we can see where the pi is. Pi is kind of hard to see, but it's above here. It's in blue. So I'm going to type in 18, and then I'm going to hit second to pull up the pi. And I get 56.5486 and so on. And it says round to the nearest tenth, so I'm going to say 56.5 would be properly rounding. 56.5, and we want to include the unit, meters. All right, moving on to area, and we'll do a similar thing. we'll leave it in terms of pi. Area is equal to pi r squared. Radius is 9. So area in terms of pi, 9 squared is 81. Pi meters squared. Area is a square unit. Make sure you put the square on your unit. And then we could go ahead and do 81 times pi using the calculator. And we could round. So this will be an approximation to the nearest tenth. It ends up being 254.5 meters squared. Right, third problem. We have the coordinate plane over to the right, and you can see I already plotted the points that are there. I did not connect them, but what happens is that these are the vertices of a triangle. All right, so I'm going to go ahead and I'm going to connect these as best that I can, straight as I can. I want to find the perimeter and area of this triangle. So when we think about it, I can easily know the length of segment AM, right? So when I look at the length of segment AM, I can see that there is 4 units. So I'll put a 4 there. And when I look at the length of segment AS, right, the height of this triangle, I'll be able to count up and see that there are 9 units in length. However, right now, just looking at the picture, I cannot quickly just count the length of segment MS here. But what I can do is what we started off in lesson 1.7 where we showed Pythagorean theorem. So we can find this, which I'm going to use this as C, and I'm going to use Pythagorean theorem. So that's how I have to start this off. If I want to find perimeter, I need to know this length as well so I can add up the sides. So I'm going to do 9 squared plus 4 squared equals C squared. So 81 plus 16 equals C squared. 81 plus 16 is 97, C squared. And I'm going to reorder. In order to solve for C, I would have been taking the square root. So this is exactly C, square root of 97. C would then be approximately equal to 9.8. There is no unit here. I'm just going to leave it off then since there's no inches or meters or centimeters, anything like that. So now, knowing that C is about 9.8, I'll go over and mark this here, 9.8. I can find perimeter. All right, perimeter of this triangle is 9 plus 4 plus 9.8. So perimeter is 22.8. Area I could have found right away. Area of a triangle is 1/2 the base of the triangle times the height of the triangle. Here's a base, here's the height. Or you could assume this is the base and this is the height. So we could have calculated area right away. So area is equal to 1/2. The base we'll use as 4, the height as 9, and area is 18. And it would be units squared. We don't have any units there though, so we'll just leave them off. All right, keep it moving. Problem number 4, and then there's one more concept after this. At first glance, problem number 4, area of a rectangle, seems pretty easy. We know area of a rectangle, right? We can find area of a rectangle by doing the rectangle's length times width, or some consider it base times height. This one, the one thing to be careful of is what I already have written down there, and I pointed it out right in the wording. We want to make sure if we're going to make an area calculation like this that our dimensions have the same unit. So we're building a rectangular deck, 4 yards wide by 20 feet long. For staining purposes, calculate the area of the surface of the deck. First thing we have to do is make sure we are using the same units, so we have to convert units. One thing we could do is we could convert yards into feet. So that's what I'm going to do. So I'm going to take 4 yards, and I want to change 4 yards into feet. So actually, I'm going to do 4 times 3 because there is 3 feet for every yard. So I end up converting and having 12 feet. So the 4 yards is going to be replaced by a 12-foot dimension. I am going to sketch a little picture here, and it's going to be 12 feet wide by 20 feet long. Okay, my picture is not to scale, but I just want you to see that I'm going to go ahead and I'm going to label my dimensions of my rectangular deck, both in feet. Now I can find the area, which is going to help me figure out how much stain should I purchase when I go to the store. 12 times 20, area of the deck in order to stain it and buy the appropriate amount of stain, 240 feet square. All right, one last thing. There is a postulate here, which is just a statement of fact. We can use non-overlapping parts of a region, and we can break it up into figures that we know, and we can add their areas together. So this is area addition postulate. So let's turn and do the sum of the non-overlapping parts. You're going to have to decide how you want to break apart the figure into figures that you can find the area of. So we're going to do the example up above. On the try again, you'll see that I have the answer, and you can try it yourself. So here we can break this up one of 2 ways. With the area formulas presented in section 1.8, the best way to break this up would be, let's give ourselves a triangle and give ourselves a rectangle. Before I get too far into this, notice these markings of congruent segments. So everywhere where there is this single slash, that's telling us that that is 4 feet. All right, so it would be helpful to go around and mark that. This dimension along the rectangle is 12 feet. So we should be able to find this dimension on the triangle by doing 12 minus the 4, and this dimension is 8. So we've labeled everything we need in order to use our 2 area formulas. So let's do area subscript t, area of the triangle, 1/2 base times height. So 1/2, we'll just use the base as 8 and the height of the triangle as 4. All right, those are the 2 that are relevant. And the area of the triangle then ends up being 16 feet square. Let's do the area of the rectangle. Area subscript r, which is simply going to be base times height. All right, the base we will just use as 12. The height is 4. So area of the rectangle is 48 feet squared. We haven't done everything because we want to know the area of the figure. So at the end, so we'll say area is area of the triangle plus area of the rectangle. And area of the triangle was 16, area of the rectangle was 48. So the answer to this, 64 feet square. All right. So after you